11. A 0.5 kilogram puck sliding on a horizontal shuffleboard court is slowed to rest by a frictional force of 1.2 newtons. What is the coefficient of kinetic friction between the puck and the surface of the shuffleboard court? Okay, so they're asking us to find the coefficient of kinetic friction. So that is what we want to know. And the symbol for that is mu sub k. And they've also told us that the mass of the puck is half a kilogram, so 0.5 kg, and that it's sliding horizontally on the shuffleboard court. So there's some friction between the puck and the court, and that's resisting the direction of motion. So the puck is sliding and it's slowing down as it's sliding, and eventually comes to rest. And the force of friction, they're telling us, is 1.2 newtons. So I'll write F for force, and I'll use the subscript small f to show that it represents the force of friction, and that's 1.2 newtons. And again, they want to know the coefficient of kinetic friction between the puck and the surface. So what does kinetic friction depend on? There's two kinds of friction, right? There's static friction, and then there's kinetic friction. So the coefficient of static friction tells us something about how much force it takes to get an object moving when it's initially stationary. There's also kinetic friction. Once the object is already moving, once the puck is already sliding, then there's a different coefficient of kinetic friction for the same object on the same surface, and it's typically less, which makes sense. It's like if you're pushing a car, it's easier to continue pushing a car that's already rolling than it is to start one moving. So we say that the coefficient of static friction is always greater than the coefficient of kinetic friction. But anyway, that's just a kind of an aside. Really, we're interested in the coefficient of kinetic friction, and it depends on the normal force, right? It depends on how hard the object, in this case the puck, pushes down on the ground. There's going to be more friction for a heavier object. If we're pushing a Mack truck instead of, a Mini, it's going to require more. We're going to have to overcome more friction and use more force. So it makes sense that the formula should be like this. The force of friction is a function of the coefficient of friction, whether it be kinetic or static. In this case, we're going to use kinetic, and the normal force. So that's what we're going to substitute into. We want to find the coefficient, and we already know the force of friction, right? They've given that to us. But what about the normal force? What is the normal force? Well, we know from earlier, from Newton's law, that in general F equals ma. Right? That's the second law. So the normal force, if you just have an object, let's draw a little picture, a little three-body diagram. Suppose this is my puck. The normal force is the force downward, and that depends on what? Gravity. So instead of ma, F equals ma, we write F equals mg, where g is the acceleration due to gravity. So we can find the normal force since we know the mass. The mass is 0.5 kilograms. And the acceleration due to gravity is 9.81 meters per second squared. I'm going to be a little bit sloppy here and just approximate it as 10. Sometimes I do this. It depends on how close the answers are. If you really want to be truly accurate, you should use 9.81. But I'm just going to use 10 meters per second squared. I'll use my calculator only when I need to. And that gives us 5 kilogram meters per second squared. That's a Newton. So it's 5 newtons. And in general, we should expect that if we're calculating a force that the answer is going to come out in newtons. And it does. So 5 newtons is the normal force. So regardless of whether the puck is moving or not, it's always exerting a downward force of 5 newtons. And of course there's an equal and opposite force back up on the puck from the surface of 5 newtons, which is why it doesn't move up or down. It's only moving side to side. Okay, so now that we have this normal force, we can plug it into our formula, and we know the force of friction, and we know the normal force, and the only thing we don't know is mu. So let's algebraically rearrange this by dividing by the normal force on both sides to get mu by itself. So mu, and by the way, this is again kinetic, coefficient of kinetic friction in this case, is going to be equal to FF divided by Fn. Force of friction divided by the normal force. Force of friction was given to us as 1.2 newtons, and the normal force we just found was 5 newtons. And that one I don't know in my head, so I'll take out the calculator. That is 1.2, help if I turned it on, divided by 5. That is 0.24. And we should expect that the answer would be less than 1. First of all the choices are less than 1. Actually, no, one of the choices is greater than 1. So the coefficient of friction is never more than 1, so we should actually eliminate 4 right away. And the answer turns out to be 1. Also, what are the units of a coefficient of friction? It's unitless, right? We have newtons over newtons, so the units cancel out, and the coefficient of kinetic friction turns out to be unitless.